Hello everyone. Today we are going to analyze this frame using cantilever method. In this frame, all of the members have the same cross-sectional area. In this frame, there are two lateral point loads, 46 kN in the point I and 23 kN in the point E. Now let us see the assumptions in the cantilever method. The points of contraflexure in both the vertical and horizontal members are located at the midpoint of each member. The axial stresses in the columns are proportional to their distances from the centroidal axis of the frame. In this frame, in the top and bottom stories, let us name the center of the columns. You can see that I have named the center of the columns M, N, O, P, Q, R, S and T. Now let us split the frame into two parts. From the center of the columns in the top story, let us take the upper part. Now let us find the location of center of gravity x bar. We are going to find x bar from the left side. We know that all of the members are having the same cross-sectional area. Let us keep the area as A. For the member IQ, the horizontal distance is 0. When we multiply area with 0, we will get 0. For the member JR, the horizontal distance is 4. When we multiply 4 with A, we will get 4A. For the member Ks, the horizontal distance is 4 plus 6, we will get 10. When we multiply 10 into A, we will get 10A. For the member LT, the horizontal distance is 4 plus 6 plus 8. We will get 18. We have to multiply 18 with the A. In the denominator, we have to add all of the areas. We have 4 areas, so A plus A plus A plus A. When we add these, we will get 32A. When we add these 4, we will get 4A. We can eliminate area. Finally, for x bar, we are getting 8 meter. We have calculated x bar from the member IQ. So the distance between the center of gravity and IQ is 8 meter. The distance between the member JR and center of gravity is 8 minus 4. We will get 4. The distance between the center of gravity and KS is 10 minus 8. We will get 2. The distance between LT and the center of gravity is 18 minus 8. We will get 10. Let us name the vertical force in the point Q as VQ, in the point R as VR, in the point S as VS, and in the point T as VT. On the left side of center of gravity, the forces will be tensile. On the right side, they will be compressive. That means on the left side of center of gravity, the forces will be acting downwards, and on the right side, they will be acting upwards. We know that the axial stresses in the columns are proportional to their distances from the centroidal axis of the frame. We know that stress is equal to force by area. For the member IQ, the stress is VQ upon area. For the member JR, the stress is VR upon area. For the member KS, the stress is VS upon area. And finally, for the member LT, the stress is VT upon area. Now let us enter the centroidal distances. For the member IQ, it is 8. For the member JR, it is 4. For the member KS, it is 2. And for the member LT, it is 10. We can eliminate area. Finally, we will get these. We can take these two terms and form an expression. In the similar way, we can take these two terms and we can make this expression. Finally, we can take these two terms and make this expression. So the expressions for VR, Vs and Vt should be made in terms of Vq. Now let us take a moment about Q. In this case, we are moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. Vt is acting in the anti-clockwise direction, so that will be positive, and the distance is 18, so 18 Vt. Vs is acting in the anti-clockwise direction, so it is also positive, and the distance is 10, so 10 Vs. Vr is acting in the clockwise direction, so that will be negative, and the distance is 4, so 4 Vr. The load 46 is acting in the clockwise direction, so that is also negative, and the distance is 2.5. For Vt, we can apply 1.25 Vq. For Vs, we can apply 0.25 Vq. And for Vr, we can apply 0.5 Vq. When we multiply these two, we will get minus 115. When we multiply these two, we will get these. When we multiply these two, we will get these. And when we multiply these two, we will get these. When we add these three, we will get 23 Vq. Finally, for Vq, we are getting 5 kilonewton. When we multiply 0.5 with 5, we will get Vr. When we multiply 0.25 with 5, we will get Vs. And finally, when we multiply 1.25 with 5, we will get Vt. We have calculated the axial forces just above the center of the columns. Below the center of the columns, they will be acting in the opposite direction. Now let us split the frame into two parts. From the center of the columns in the bottom story, let us take the upper part. In the points R, S and T, we have made the expressions for the axial forces in terms of VQ. In the similar way, we can make expressions for Vn, Vo and Vp in terms of Vm. Now let us take a moment about M. Vp is acting in the anti-clockwise direction, so it will be positive and the distance is 18, so 18 Vp. Vo is acting in the anti-clockwise direction, so that will be positive and the distance is 10, so 10 Vo. Vn is acting in the clockwise direction, so that will be negative and the distance is 4, so 4 Vn. 46 kilonewton is acting in the clockwise direction, so that will be negative and the distance is 5 plus 2, we will get 7. 23 is acting in the clockwise direction, so that is also negative and the distance is 2. For Vp, we can apply 1.25 Vm. For Vo, we can apply 0.25 Vm. And for Vn, we can apply 0.5 Vm. After the calculation, we are getting Vm, which is equal to 16 kilonewton. When we multiply 0.5 with 16, we will get Vn. When we multiply 0.25 with 16, we will get Vo. And finally, when we multiply 1.25 with 16, we will get Vp. We have calculated the axial forces just above the center of the columns. Below the center, they will be acting in the opposite direction. Now, using these axial forces, we can find the shear forces in the beams. First, let us find the shear force in the member IJ. For that, let us take the joint I. When we take the joint I, we should not take the whole members IJ and IE. Only we have to consider up to the center. In the joint I, let us apply the rule sigma V is equal to 0. The axial force 5 is acting downwards, so that will be negative. Let us keep the shear force as V. It is acting upwards, so that will be positive. Finally, for V, we are getting 5. Let us enter that. Now, let us take the joint J. 5 is acting downwards, so that will be negative. 2.5 is also acting downwards, so that is also negative. Let us keep the shear force as V. It is acting upwards, so that will be positive. Finally, for V, we are getting 7.5 kilonewton. Let us enter that. Now, we are going to find the shear force in the member KL. For that, we can use the joint K or the joint L. Let us use the joint L because it will be easy for us. Let us take the joint L. The shear force is acting downwards, so that will be negative. This force is acting upwards, so that will be positive. Finally, for V, we are getting 6.25 kilonewton. Now, let us find the shear force in the member GH. For that, let us take the joint H. The shear force is acting downwards, so that will be negative. This force is acting downwards, so that is also negative. This force is acting upwards, so that will be positive. Finally, for V, we are getting 13.75. Let us enter that. Now, let us find the shear force in the member FG. Let us take the joint G. The shear force is acting downwards, so that will be negative. This force is also acting downwards, so it is also negative. This force is acting upwards, so that will be positive. And this force also acting upwards, so that is also positive. Finally, for V, we are getting 16.5. Let us enter that. Now, let us find the shear force in the member EF. Let us take the joint E. The shear force is acting upwards, so that will be positive. This force is acting downwards, so that will be negative. This force is acting upwards, so that will be positive. Finally, for V, we are getting 11 kilonewton. Let us enter that. Now, we are going to find the moments. The moments in the columns will be acting in the anti-clockwise direction. You can see that all of the movements in the columns are acting in the anti-clockwise direction. The movements in the beams will be acting in the clockwise direction. You can see that all of the movements in the beams are acting in the clockwise direction. In a member, the movements will be same at both of the ends. For example, let us take the member IE. Here MIE and MEI will be same. And when we take the member IJ, the moments MIJ and MJI will be same. Now let us use the shear forces and find the moments in the beams. To find the moments, we have to use the formula WL upon 2. First, let us take the member ij. Here W is 5, L is 4. So for Mij and Mji, we are getting 10. Now let us take the member jk. Here W is 7.5, L is 6. For mjk and mkg, we are getting 22.5. Now let us take the member kl. Here W is 6.25, L is 8. For MKL and MLK, we are getting 25. Now let us take the member EF. Here W is 11 and L is 4. For MEF and MFE, we are getting 22. Now let us take the member FG. Here W is 16.5 and L is 6. For MFG and MGF, we are getting 49.5. Now let us take the member GH. Here W is 13.75 and L is 8. For MGH and MHG, we are getting 55. In the joint I, if this moment is 10, the moment MIE also should be 10. So MEI also should be 10. In the similar way, we can find MLH and MHL. Both of them should be equal to 25. We can find MJF by adding these two moments. We are getting 32.5. So MFJ also should be 32.5. We can find MKG by adding these two moments. We are getting 47.5. So MGK also should be 47.5. Now let us find MEA. For that we have to subtract 10 by 22. When we do that, we are getting 12. We know that MEA and MAE will be having the same value. Let us find M of B. For that we have to add these two moments and then we have to subtract this moment. When we do that, we are getting 39. We know that M of B and MBF will be same. Now let us find MGC. For that we have to add these two moments and then subtract this moment. When we do that, we are getting 57. We know that MGC and MCG are same. Now let us find MHD. For that we have to subtract this moment by this moment. When we do that, we are getting 30. We know that MHD and MDH are same. In this frame, we have calculated all of the moments. We have calculated the shear forces in the beams. Now let us find the shear forces in the columns. First, let us find the shear force in the member IE. For that, we have to add these two moments, so 10 plus 10, and then we have to divide by the length 5. When we do that, we will get 4. Now let us find the shear force for the member JF. For that, we have to add these two moments, so 32.5 plus 32.5. Then we have to divide by the length 5. When we do that, we will get 13. Now let us find for the member kg. For that, we have to add these two moments, so 47.5 plus 47.5. Then we have to divide by the length 5. When we do that, we will get 19. Now let us find for the member LH. For that, we have to add these two moments, so 25 plus 25, and then divide by the length of 5. When we do that, we will get 10. Now let us take the member AE. Here we have to add these two moments, so 12 plus 12, and then we have to divide by the length 4. When we do that, we will get 6. In the similar way, we can find the shear forces In the remaining members, we have calculated all of the shear forces. Now we are going to find the axial forces in the beams. For that, we have to use the shear forces in the columns. Since these 2-point loads are acting towards the right side, the axial forces in the beams will be compressive. Now let us take the joint I. In this joint, let us apply the rule sigma h is equal to 0. 46 is acting towards the right side, so that will be positive. The shear force 4 is acting towards the left side, so that will be negative. Let us keep the axial force as H. It is acting towards the left side, so it is also negative. Finally, for H, we are getting 42 kilonewton. Let us apply that. Now, let us take the joint J. 42 is acting towards the right side, so that will be positive. 13 is acting towards the left side, that will be negative. H is also acting towards the left side, so that is also negative. Finally, for H, we are getting 29 kilonewton. Let us apply that. Now, let us take the joint L. 10 is acting towards the left side, so that will be negative. H is acting towards the right side, so that will be positive. Finally, for H, we are getting 10 kilonewton. Let us apply that. Now, let us take the joint H. 10 is acting towards the right side, so that will be positive. 15 is acting towards the left side, so that will be negative. H is acting towards the right side, so that will be positive. Finally, for H, we are getting 5 kilonewton. Let us apply that. Now, let us take the joint G. 19 is acting towards the right side, so that will be positive. 28.5 is acting towards the left side, so that will be negative. 5 is also acting towards the left side, so that will be negative. H is acting towards the right side, so that will be positive. Finally, for H, we are getting 14.5 kilonewton. Let us apply that. Now, let us take the joint F. 13 is acting towards the right side, so that will be positive. 19.5 is acting towards the left side, so that will be negative. 14.5 is acting towards the left side, so that is also negative. H is acting towards the right side, so that will be positive. Finally, for H, we are getting 21 kilonewton. Let us apply that. Previously, in this analysis, we have calculated the axial forces in the columns. Now, we have calculated in the beams. Now, using the movements, we are going to draw the bending moment diagram. Here, you can see the bending moment diagram for the columns. Here, for the beams. Now, we are going to end this session. Thank you for watching this video.